Hello students, today I am here to teach you find the intervals in which the function is increasing or decreasing. I mean the students of class 12 exercise 10.1 application of derivative from BMath. That's why this video has focused to the students of class 12 how to find the intervals in which the function is increasing or decreasing. Here the function is given here, fx is equal to 2x cube minus 24x plus 5. So solution fx is equal to 2x cube minus 24x plus 5. This function is given. First of all, you have to find derivative of function. So derivative of function, to find f dash x is equal to, this is the symbol of derivative. I mean f dash x means derivative of fx equal to d 2x cube minus 24x plus 5 by dx, means derivative of fx, derivative of 2x cube minus 24x plus 5 equal to 2 into derivative of x cube, power rule you have to use, 3 into x power 3 minus 1 minus 24x, derivative of 24x, 24 into x power is nothing, that means is 1. So according to the power rule, 24 into 1 into x power 1 minus 1 plus 0. Derivative of 5, derivative of constant number is 0, any constant number, either it is 5 or 10 or 100 or 1000, any constant number of derivative is 0. That's why derivative of 5 is equal to 0 plus 5 equal to 3 to the 6x square minus 24 x power 0, 1 minus 1 means 0, that means x power 0, x power 0 is equal to 1, 1 into 24 means 24. So 6x square minus 24, we can take 6 common, then it will be x square minus 6 for the 24, x square minus 4 equal to 6 into x square minus 2 square, we can do x square minus 4 means 4 2 square, 2 into 2 is equal to 4. Now this is in the form of a square minus b square, it is in the form of a square minus b square. That's why 6 into a square minus b square formula if we use, then it will be a minus b means x minus 2 into a plus b means x plus 2. Then its derivative is 6 into x minus 2 x plus 2. It is the derivative. Now to find the intervals, derivative is equal to 0 we have to do. So now derivative of function fx is equal to 0, means f dash x is equal to 0 in order to find the intervals, that is also known as the clinical points. So first derivative x is equal to 0 or 6 into x minus 2 into x plus 2 equal to 0, or x minus 2 x plus 2 is equal to 0. Therefore either x minus 2 is equal to 0 or x plus 2 is equal to 0, we can write either x minus 2 is equal to 0 or x plus 2 is equal to 0. Therefore x is equal to 2 or x is equal to minus 2. That's why value of x is Therefore, we can say value of x is -2 comma +2. I mean either x value is -2 or 2. This is the value of x. That's why, listen here, this divide the number line in 3 intervals. Once you look here, suppose this is the number lines -2 and this is +2, -2 +2. It has divided the intervals in 3 parts. One is this, next is this and this. These 3 parts are called open intervals. These 3 parts are called what? Open intervals. I mean -2. This is the x is smaller than -2. X is smaller than -2, and this is x is greater than -2 and smaller than 2, and this is x is greater than 2. I mean we can write these divides the number line. This divides the number line in 3 open intervals. This divides the number line in 3 open intervals. Named x is smaller than -2, and one interval is x is greater than -2 and smaller than 2, and x is greater than 2. I mean this interval is x is smaller than -2, this is x is greater than -2 and smaller than 2, and this interval is x is greater than 2. These are called 3 open intervals. So case first, when x is smaller than -2, then f dash x. Here, I mean either it is increasing or decreasing. You have to find here if the value of first derivative is in the positive, then function is increasing, and value of first derivative is in negative, then function is decreasing. That's why in order to find increasing or decreasing of the function, we have to find the value sign. We can say either the value of fx is positive or negative. For this, what you have to do, look at here, x is smaller than -2. I mean x value is not equal to -2. X is smaller than -2 and it is indefinite. It means value of x is indefinite and less than -2. So value of x can be -3 also, can be -4 also, can be -5 also, can be -6 also, and so on. Yeah, that's why value of x we should put in the derivative less than -2, any value. So when we put any value of x less than -2 in the derivative in this, once you see there, derivative is 6 into x minus 2 x plus 2. When x value if we put less than -2, smaller than -2, that means -3 can be, -4, yeah. So if x value -3 if we put, then -3 and -2, what will be here? -3 -2, and in place of x if we put -3, then this will be -3 -2 means -5. The sign will come minus, -5, that's why here minus. into. Now see here. Again x value minus 3. Same value here you have to put in x plus 2 also. X minus 2 into x plus 2. So minus 3 plus 2 is equal to minus 1. It means sign came what? Again minus. Now this minus and minus multiply, then result will be positive. Plus minus into minus, the result will be plus positive. Since the result is positive, then function is increasing. I have told you, when the value of first derivative is positive, then function is increasing, and value of first derivative is negative, then function is decreasing. So it is clear. Here we can write, since therefore first derivative is greater than 0, is positive, that's why greater than 0. So fx is increasing for all x is smaller than minus 2. Case second now. Case second. In second case, I have said you these points I divide the number line in 3 intervals. First interval already we calculated. Now second interval. Case second. In case second, when x is greater than minus 2 and smaller than 2, then when x is greater than minus 2 and smaller than 2, then first derivative f dash x. Again we have to calculate the sign. Either the sign is positive or negative. Look at here. X is greater than minus 2 and smaller than 2. It means value of x minus 2 and 2 plus 2 does not belongs in the value of x. Do not belongs in the value of x minus 2 and plus 2. Value of x greater than minus 2 means that can be minus 1, that can be 0, that can be 1. Yes. So minus 1, 0, 1. X value, the value of x in this condition will be minus 1, 0 and 1. So any one value put in the derivative here, and we can calculate the result is positive or negative. Look at here, when you put the value of x, suppose minus 1, then x in place of x is minus 1. Minus 1 and minus 2, minus 3. Result will be minus here into. Here minus 1 if we put, then minus 1 plus 2, the result will be plus. Now see here, minus and plus multiply, then the result will be minus, means negative. The result will be what? Negative. It means when the result is negative, then it is clear the function is decreasing. Yes, I have told you, when the result derivative value is positive, then function is increasing. Value of derivative is negative, then function is decreasing. That's why here, therefore f dash x is smaller than 0, so fx is decreasing for all x is smaller than minus 2 and x is greater than minus 2 and smaller than 2. Now third case. Look at the third case. In third case, x is greater than 2. Case 3. Fx when x is greater than 2, then derivative. Now again x is greater than 2, then we have to calculate the value of derivative, either is positive or negative. So x is greater than 2, that means x value can be 3, can be 4, can be 5, can be 6. Its value is indefinite. So any value except 2 means x value is greater than 2, no? So 2 is not the value of x. So x value we can put 3, you can put 4. So when we put x is equal to 3 in the derivative, look at here, 6 into x minus 2, x plus 2. When value of x is 3, then 3 minus 2, result will be 3 minus 2, result will be plus 1. That's why its result is what? Plus into. Again, x value if we put plus 3, then 3 plus 2 is equal to 5. Plus 5, it means result is plus. Plus into plus multiply, then result will be plus, means positive. The result is positive. That's why it is clear the function is increasing, because the result value of derivative is positive. So since here, therefore f dash x is greater than 0, so fx is increasing. Fx is increasing for all x is greater than 2. So in this way we can find the intervals in which the function is increasing or decreasing. So here we can write at last, therefore fx is increasing at fx is increasing at x is smaller than minus 2. X is smaller than minus 2, and again increasing at x is greater than 2. X is greater than 2 and decreasing at x is greater than minus 2 and smaller than 2 at last. That's why in this way we can find the function intervals in which the function is increasing or decreasing. Understood or not? So of course I think you might have understood. If you have any problems, I have always told you, you can share your problems through messenger. I will try my best to solve it. Thank you.